This is the introduction to Activity 2.5, Extended Sequences and Linear Functions. In this activity, we'll learn to extend sequences and graphs to an integer index set. We'll learn to use white and opposite white end strips, and we'll investigate the features of linear functions. Our materials will be black and red tiles and white and opposite white end strips, which are introduced in this activity. You may have noticed that sometimes it seems reasonable to extend our graphs backwards. Here's a graph for t of n equal to n plus 2 for n equals 1, 2, and 3. It makes sense to extend this backwards when n is 0, -1, -2, -3, and -4. This is an extended graph. It also makes sense to visually extend the tile figures backwards for when n is less than or equal to 0. Here's an example. You can see that each of these tile figures corresponds to the function relationship t of n equals n plus 2. Because the slope is 1 here, the coefficient in front of the n is 1. The function values go up by 1. So you can see the function value when n is -4 is -2, and then that goes up to -1, then 0, then 1, then 2, then 3, then 4. You could have more complicated figures, but these figures have simple black and red tile representations. Now suppose you'd like to model the nth figure. Could we use a black end strip? If we had a black end strip and some black tiles, there's no way we could ever get red tiles. For example, for n equals -3, we need 1 red tile. We could never get that if we used a black end strip. How about a red end strip? Well, if we had a red end strip and a couple of black tiles, then we could never get, for example, the 4 black tiles for figure 2. Neither the black nor the red end strip work. So let's look at white and opposite white end strips. The white end strip value is n and matches the input. When n is positive as an input, n is positive as an output for the white end strip. When n is negative for an input, n is negative for an output for the white end strip. For the opposite white end strip, which you can see there are little O's on the strip, this has the variable -n. So when n is positive as an input, the output is negative, and when n is negative as an input, the output is positive. Let's look at these dimensions. Just like with a black and red end strip, the white end strip dimensions are always n, so they can be 1 times n or -1 times -n. Remember, these n's can be positive or negative. But just thinking about the dimensions as 1 times n and -1 times -n should make sense. Similarly, for the opposite white end strips, we want to get -n, so it can be 1 times -n or -1 times n. We can now combine all these features to get a bigger picture. So here is our graphical representation, and our figure n is a white end strip and 2 black tiles. Our function is t of n equals n plus 2, and our index is the integer 0, ±1, ±2, etc. Let's see why figure n, the white end strip and 2 black tiles, works. If we had figure 4, figure -4, the white end strip would be 4 red tiles. 4 red tiles and 2 black tiles reduces to 2 red tiles, which matches our sequence. On the other hand, for figure 2, the white end strip would be 2 black tiles, and 2 black tiles plus 2 black tiles is 4 black tiles, which matches. From now on, we'll use the white and opposite white end strips instead of the black and red end strips. And just like with the black and red end strips, a white end strip and an opposite white end strip is a zero pair. Let's look at some graphing terms. When 2 lines cross, they intersect, and the point where they intersect is the point of intersection. For any function t of n, the coordinate pair 0, t of 0 is called the t-intercept, and it's the point where the graph crosses the t-axis. For example, 0, 2 is the t-intercept for t of n equal to n plus 2. For a function t of n, the coordinate pair n0 is called the n-intercept, and it's the point where the graph of t of n crosses the n-axis. We find this by setting t of n equal to 0 and solving, for example, n plus 2 equals 0, so n equals -2. The n-intercept for t of n equal to n plus 2 is -2, 0. Let's look back at our graph, and you can see our n-intercept here, -2, 0, and our t-intercept, 0, 2. You may recall the formula for finding the slope of a line. For 2 points, n1, t1, and n2, t2 is m, that's the slope, is t2 minus t1 divided by n2 minus n1. And 2 lines with the same slope are parallel lines. When you sketch white and opposite white end strips, you can again just draw a rectangle and label them with n or minus n. And you can label edge pieces by just drawing lines as well if you need the edge pieces. You won't need edge pieces in activity 2.5.